All right, I think we can start. So good morning or good afternoon, everybody, and welcome to this session. Our topic for the next 60 minutes will be OpenSearch and best practice around Amazon OpenSearch migrations. My name is Michael Ivanov, and I'll be your host for the entire session. If you have any questions related to logistics or the content, so feel free to ping me in the chat directly. A few housekeeping items. If you have any question, feel free to post the question into the chat, and we'll try to pick it up immediately. We also have a dedicated Q&A session in the end, so you might want to keep the questions to the end if you prefer. Um, we will be sharing a link to a survey, so please share your feedback. This will be in the end of the session. I think that's all related to housekeeping. So with this, let me introduce Handy Wijaya, who is our OpenSearch champion, who will be diving deep into the migration strategies. Handy, please take it from here.
Thank you for the introduction, Michael. Hi, everyone. Good morning, good afternoon, good evening, wherever you are joining in. Welcome again to today's session on Amazon OpenSearch Service migration. The promise of today's session is to make you well informed on different steps and options when making design decision of migrating from self-managed Elasticsearch, relational database, log analytics, and observability solutions into Amazon OpenSearch service. So we'll start with a brief introduction on OpenSearch itself. OpenSearch is an open source project under Apache 2 license that was launched back in April 2021. So today we have active community of contributors with organizations like SAP, Capital One, Red Hat, publicly backed OpenSearch. Historically, OpenSearch was derived from Elasticsearch version 7.10.2, which is the last version of Elasticsearch that uses Apache 2 license as an open source project, while the OpenSearch dashboard is forked or derived from Kibana project version 7.10.2. Since then, we have built a number of different features like security, anomaly detection, alerting, observability plugins, search relevance, and so much more. Today, you can deploy OpenSearch in 3 different options. You can deploy it as a self-managed cluster running on your EC2 or on top of your Kubernetes cluster. We do maintain Helm chart for that. The second option is, which is where majority of the customer uses and benefits from, are using the Amazon OpenSearch service as a managed service, or the Amazon OpenSearch serverless as a serverless options of the managed service. So 3 different options. The latest options of Amazon OpenSearch serverless is generally available. We launched it back in January this year, 2023. Customer today use OpenSearch in 2 major use cases. The first use case will be what we call a search use case. This is where you have documents, you have products, or you have other entities, or you have repository that you like to index and search. It has support for different complex queries, different ranking of your queries, sorting, and so much more. The second use case that the customer use Amazon OpenSearch for is for log analytics. This is where you send your log file from your containers, from your servers, from your network devices or firewalls into Amazon OpenSearch service, and then you create visualization, dashboard, alerting, and even anomaly detection on top of those logs. The first use case of search use case in terms of the characteristic is usually read heavy, where you have a lot of read operation, but not so much on the write operation, while the log analytics characteristic is write heavy, where you have a lot of writes operation going in, typically from a streaming source, and less of a read operation. The trending customer use case from those two major use cases, the first one is we have an AI-powered search where your search can be done through a semantic search or visual search, or a custom ranking or custom scoring for your search result. And then we have a powering AI with OpenSearch. This is also in the rise with the use of vector store or vector database with projects like Llama Index and Haystack supporting OpenSearch as their vector store. On the log analytics use case, the trending customer use case that we've seen is we've seen customer running petabyte scales of cluster, ingesting a large number of log or traces, even metrics into their cluster. And then we also seen customer use Amazon OpenSearch for their security analytics use cases. In the current state of Amazon OpenSearch migration specifically, this year we have published a technical white paper guide on migration back in January 2023. This technical white paper guide was written based on our expertise and experience working with a number of customer doing migration to Amazon OpenSearch service. And then recently in April of 2023, AWS launched a new managed service for data prepper named Amazon OpenSearch Ingestion. Customers can utilize this service to ingest data from various sources like Amazon S3, and then from transformation and index to Amazon OpenSearch. So this is a managed service. You don't have to manage your own compute instances. It is provisioned in a serverless manner, so you can benefit from less overhead. While the other alternatives will be using something like Logstash or running Data Prepper in your own virtual machine on EC2, which remain popular options due to a large community support in different data sources plugins. So before starting your migration journey, it is always good to validate your motivations and expected benefit in migrating to a new system such as Amazon OpenSearch service. So we start with the challenges of managing your own search cluster. Search cluster, a modern search cluster by nature are distributed systems where you are dealing with different components, different services, and different piece of infrastructure that will make the entire distributed system of a search cluster. Managing and scaling this distributed system requires dedicated expertise because of the nature of the distributed system itself. And this in in our experience, drive up the total cost of ownership with a dedicated DevOps engineer and dedicated operators that you need to assign to self-manage this search cluster. And then with a self-managed search cluster, you need to build or pay extra for advanced security modules, alerting, and other features such as the self-healing or the self-recovery capability. And on top of that, you still have to purchase and manage your own infrastructure. You still have to purchase your own virtual machines in EC2s, for example, and you have to manage the networking side of those EC2 as distributed system nodes. The last benefit of, or the last challenge in having a self-managed search cluster, which most customer overlook, is when you have a distributed system like Amazon OpenSearch service, you achieve high availability by deploying multiple nodes in different availability zones. When you have that in EC2, you will incur inter-AZ data transfer because these nodes will constantly talk to each other for high availability. They will constantly replicating data to each other across availability zone. This incur inter-AZ data transfer when you have this multi-AZ setup. The inter-AZ data transfer can go up significantly when you have a large cluster with more nodes and more replica of your data across AZ. The other benefit or motivation to move from non-search cluster, but other solutions, for example, log analytics or observability solution, or any data warehouses to Amazon OpenSearch, the primary motivation that we hear from the field is the cost. A lot of this solution comes with a package solution, which means that you may not use all of the features, but you're paying for all of them. Now, Amazon OpenSearch service is a search cluster, and the way that we achieve additional features or functionality is by the use of plugins. So you have the Amazon OpenSearch service as a search cluster itself, and as part of the managed service, we also include certain plugins that you can use for alerting, monitoring, traces, service map within the observability. And the third challenge with other solution is the lack of different storage tier. In Amazon OpenSearch service, customer can leverage different storage tier for a cost optimized data lifecycle. This is typically used in a log analytic use case. Within Amazon OpenSearch, customer can leverage different storage tier. So you can have your older logs stored in the lower storage tier for cost optimization. In this example, you can have a hot tier, which is the default data node tier that is backed by EBS or attached SSD storage. And then the next tier will be ultra warm, where you have instances backed by S3, and the next tier will be cold storage, where you can store or archive your data in a near S3 cost for years of retention. So the graph on the right side simulates how the costs with ultra warm and cold storage tier help you to optimize the total cost of your index data. This is considering that you're storing a 1 terabyte logs in a single day. Now that we cover the challenges and the benefit and motivations of moving to managed service such as Amazon OpenSearch service, we will discuss the steps and a typical customer journey in the migration. We have worked with many different customers from different vertical industries and different migration sources. Based on those expertise and experience, this year we published this technical white paper, and this has helped a number of customers accelerate their migration journey as well. An Amazon OpenSearch migration journey consists of 6 different phases, with step 4 and 5, data migration and cutover, being the critical ones that will decide on whether or not you have reached the point of no return, and if you require any downtime budget. If yes, how long will that downtime budget require? The first phase of your migration is making sure that you make all the appropriate planning. This is important because this phase will help you decide on the requirements on the next 5 phases. In the planning phases, your design decision will be influenced by 8 different focus areas, where the majority of your activities, discussion, and meetings will be spent typically on 3 focus areas, which are sizing, data flow, version dependency, and deployment framework. When it comes to sizing in Amazon OpenSearch service, we start by the storage requirement, then the CPU requirement, then the instance type requirement. With storage, we need to size the required index size that will decide the number of storage that you need, the number of nodes that you need, the size of those nodes, and the number of shard that is required in that cluster. Shard in OpenSearch is a logical representation of a Lucene index, which is actually a Java process. So the actual process that will consume resources, be it CPU or memory, in your OpenSearch cluster, again, as a distributed system, are shard, which is actually the Java process, and the actual worker in the system itself. So when we size the cluster, we typically use a 1.2 up to 1.25 multiplier against the source data. And the source data can be something in your relational database or can be something in your log files. And then the 2 multiplier is to multiply that source data with the replica. Within Amazon OpenSearch, we have a concept of primary shard where the write operation happens, and we do have a concept of replica shard where replica can be used for read operation and high availability. The numbers for guiding the sizing of the number of shard is each shard will address 30 gig worth of index data in search use case and 50 gig worth of index data in the log analytics use case. So if you have a 100 gig of logs, typically you will need 2 shard. And if you have a 60 gig worth of search index, then you will need 2 shard as well. The second sizing area will be based on the CPU, and the total of free CPU that you typically require is 1.5 times the active shard. So active shard in logs analytics can be counted as the number of shard that is actively used in write operation and the read operation. In the beginning, we discussed how the search use case are mostly read intensive and the log analytics use case are mostly write intensive. This will help us decide on how many fee CPUs we require to support those different operation of read and write. The third sizing components that we need to decide is the instance type. Typically, customers start with R6 as a starting point for the data node. R6 is our latest instant family in Graviton that requires a minimum version of Elasticsearch 7.9 or OpenSearch 1.0. So if you are targeting a lower version than that, then you can use i3 or R5 as your starting point and capture the performance characteristic from that instance type. If you need more CPU, then you can have a C instance class for your CPU requirement, while in Amazon OpenSearch service, you decide on two types of nodes. The first nodes will be your data node, and the second will be your dedicated leader node. With dedicated leader node, we recommend a C instance class, so it can be a C5 or C6 instance class for your dedicated leader node. I want to quickly address the questions from the chat box. The sizing vary from vector search use cases. So vector search use cases are still considered the search use case. So far, I've seen the characteristic is pretty similar with the search use case. So the target size is 30 gig and the the total fee CPU is still 1.5 times the active shard. The only different in vector search is the search frequency or the read operation can be very high and can be very frequent in nature. In that case, where you have because certain LLM behave differently, but LLM tends to have a lot of concurrent read operation. What you can add into the sizing is actually size for more replica because replica will help that additional or their had concurrent search operation going in. So instead of sizing for 2 replica, you might want to consider having 3 or 5 replica to support those read operation. And in a read heavy operation, uh, you can have an instance type where the storage is not EPS, but the storage is attached SSD. So that's also another sizing consideration when it comes to search use case. The next aspect of planning your migration journey is to make sure that you decide on the data flow because in a search cluster typically it will work in pair or it will get the source entities or documents from a different source of truth. So this source of truth can be a relational database in a search use case. This source of truth can be a log files spreading in your container fleet, for example. So the next key focus area in planning is to make sure that you have a data flow from your old cluster to your you have a data flow that works from the source to your old cluster, the same data flow will also work from your source to the new target cluster. So you'll answer certain things like, can you easily swap up the search engines, or the data flow source works interchangeably, or you have to change certain components on the data flow as well. Do you have an open source ingestions, or do you have a very vendor specific ingestions that you might need to change, or you might need to add extra component on top of that? Or and then the third option, um, the third discussion will be, can you reuse the existing implementation, or you have to upgrade certain version in your data flow. So this is making sure that you're not just migrating the data sitting in your old cluster or your current cluster. This is making sure that whatever data flow you have external from that cluster will still remain usable, will still remain online going into the new cluster. The next key area for planning is your version dependency. This is typically discussed in a search use case where you have an external application like your container application or your backend API interacting with the search cluster. So if you have, for example, if you have a web application that use Elasticsearch client, you need to make sure that the Elasticsearch client will still work with the target cluster that you have, or you need to change the client implementation. Certain libraries in certain programming language doesn't have like a native support for authentication, for example. Within Amazon OpenSearch service, you do have an option to use basic authentication, or our recommended authentication will be IAM authentication from your application. So certain client libraries doesn't support IAM authentication. So if you are migrating to Amazon OpenSearch service, following the security best practice, you might need to change your client library. We, as part of the open source project, we do support OpenSearch clients on different programming languages. So other things to consider is if there is any specific features that is supported only in certain version of your search cluster. So this is if you have a Elasticsearch cluster, for example, and there are some commercial or premium subscription, you need to evaluate whether that specific features also supported with Amazon OpenSearch service, or it's supported in a different way. And the the next focus areas to consider when it comes to version dependency is to decide whether you can upgrade to newer version for better security and stability. Security being that with the latest version or newer versions of Amazon OpenSearch service, there are a number of different security options available. The IAM authentication I mentioned earlier is not available on the older version, but is available on the newer version of Amazon OpenSearch service. Stability being that with the newer version of Amazon OpenSearch or newer version of OpenSearch itself, we do follow the newer version of the Lucene. Lucene is a different open source project entirely. They have different version and version release. With newer version of OpenSearch or Elasticsearch, the Lucene version also got upgraded to a newer version that will add the cluster stability as well. Next in planning will be deciding on your deployment framework. If you are already using an infrastructure as code, such as CloudFormation or Terraform, Terraform and CloudFormation does support provisioning and managing your infrastructure through CloudFormation templates and Terraform models. The other aspect of the deployment framework, apart from the infrastructure as a code, will be to address the change management. So if you have any tools that you use for change management, for example, your database schema evolutions or database schema permission, things like Chef, Puppet, or even Jenkins, you can still use them to manage change within Amazon OpenSearch service. So OpenSearch itself support many programmatic APIs for change management. So for change management, you can have your, for example, you can have an index mapping or index template in any Git repository, and you can use as simple as Lambda function that gets triggered every time you make changes, or you can use tools that is already in your environment. So for infrastructure as a code, CloudFormation and Terraform are two of the available options. For change management, we would recommend you to use whatever tools you have already in your environment. The next step in your migration journey is to establish typical proof of concept success criteria. You need to secure funding to right size your cluster. Again, size your cluster is important to make sure that you got the performance that you wanted, be it a search use case or log analytics use case. And then you define the success criteria. If it's a search use case, typically you want to measure the relevance of your search result against certain user group or certain focus user group. If it's log analytics, you want to make sure the usability of the search through your SLI or SLO runbooks against those log analytics dashboard visualization or alerting. The anti-pattern for this phase is do not just start by deploying a domain. Make sure it's right size for your proof of concept. Make sure you have a clear criteria on what a successful proof of concept looks like. And for migration, data migration, it is critical to time box your testing so you can have a simulated testing of migrating partial of your uh, log data. For example, if your log data lives in a different system, you can partially migrate that as part of the proof of concept that will give you an understanding on the duration of the data migration that you need. And make sure that you exercise all portion of the stack during the proof of concept, not just a single stack, which is data migration. The presentation layer, which is authentication and authorization. If you do have a SAML authentication for your operator going to the dashboard, you should test it in this proof of concept phase. If you have a rendering UI for your search application, this is where you should test it as well. And ingestion layer for the collection, the buffering, aggregation, and store. This is related to the first phase of key focus area within the data flow. This is where you test the data flow is working correctly from the source of truth into the Amazon OpenSearch service. The third phase in your migration journey will be deploying the target migration cluster or infrastructure or any other infrastructure components in your production environment. This is where you get to exercise the deployment automation and validate it works as expected in terms of the infrastructure And then IAM permission, it requires security aspect and monitoring as well. We do have a recommended CloudWatch alarm for Amazon OpenSearch service that you can enable. This will help you to build an SLI or SLO surrounding the cluster health or the cluster stability. And in this deploy phase is where we recommend customer to finalize their runbooks in related to ingestion, in related to performance, in related to troubleshooting or incident response surrounding that their Amazon OpenSearch service cluster. The next phase, which is one of the critical phase in your migration journey, will be data migration. Based on the inputs, based on the activities of the first three phases, you will have a inputs, you will have um, enough knowledge to do the data migration, because we do have different options for you to perform data migration from your current or old cluster or data store into Amazon OpenSearch service. If you are migrating from another OpenSearch, self-managed OpenSearch, or self-managed Elasticsearch, there are specific migration options available for you. One of the most popular options is Snapshot and Restore. So if you have a self-managed OpenSearch or self-managed Elasticsearch, you can use Snapshot and Restore to take a snapshot of your current cluster and then restore it to the new one. The other options available will be remote Reindex, and we will talk about it in a next few slides. And you do have another option to use tool-based migration such as Logstash or Data Prepper. For a migration option where you are migrating or continuously replicating from a relational database, then using AWS specific service like AWS DMS or database migration service is one of the possible options. Some database has a specific export feature. This is for your first migration or full load migration to intermediate storage like an EBS or NFS or Amazon S3 bucket. So this is also some options that you can do. But if your source is relational database, you'll be dealing mostly with the capture data chains, the CDC process itself. The full migration options are typically happen only once, and after that, you need to set up a CDC pipeline that continues to replicate to OpenSearch. With other service provider or sources that is not supported with the existing tool, customer can build directly from source using custom code that will read from the source and then write into Amazon OpenSearch, or again, use an intermediate buffer such as Amazon S3. Well, Snapshot and Restore is one of the most popular options because it's simple, it doesn't take so much effort. It has some caveat with the platform support. For example, it's only supported for Elasticsearch and OpenSearch to Amazon OpenSearch service. It does have a limitation of compatibility where you can only restore an older version of the cluster to a newer version of the cluster by one major version or one minor version ahead difference. But if you are migrating to the exact same version, then Snapshot and Restore will work just fine for you. And Snapshot and Restore is not a continuous process. It is a point in time snapshot and restoration that sometimes require you to stop ingestion at the source or to replicate subsequent data afterwards. and we'll discuss this in the fifth phase, which is the cutover. With Snapshot and Restore, the snapshot is actually stored in Amazon S3 bucket as a repository to be able to restore into an Amazon OpenSearch service. Doesn't require any direct connectivity between the target and source cluster, but both should be able to reach Amazon S3 endpoint. Two of the important repository setting that we've seen customer benefit by fine-tune these two settings are the maximum snapshot byte per second. By default, this is 40 megabytes, so you can increase this to 1 gigabyte or 2 gigabyte to accelerate the snapshot process into S3 bucket. And same goes with the maximum restore byte per second. This is something that you can fine tune depending on your instance capacity in terms of the network bandwidths and the IOPS as well. With remote Raindex is different with Snapshot. This requires, there is no intermediate repository needed, but it requires a network connectivity between the source cluster and the target cluster. Remote Raindex is relatively slower than Snapshot and Restore. However, it does provide flexibility in terms of the target. Raindex can have a different schema mapping and setting from the source index. There are certain newer version of Elasticsearch above 7.10.2, which is where we fork OpenSearch, that has restriction in using remote Raindex to certain OpenSearch version. So you may need to test that version. If you are using a latest version or newer version of Elasticsearch, you may need to test the Raindex in a smaller subset of data before doing full remote Raindex. It uses Raindex API. It consumes read and write throughput on both cluster. We do have a list of recommended best practices of settings and configuration that you should enable before doing Raindex. One of my colleagues, Arun, has put this in a small application that will set all of those best practice configuration before you perform a Raindex. The link for that application is listed in the slide. It is published in GitHub that you can use when you want to use remote Raindex. The next options that you have is to use a tool-based migration like Logstash or Data Prepper. With the first two options, Snapshot, Restore, and Remote Raindex, you do not need additional compute instance to run those migration options. With a tool base, you need to run this tool in a separate compute instance that has network connectivity to both the source and the target. It also perform document per document migration, which means it provides flexibility across different versions. And it also provides the same flexibility with remote Raindex, where you can have different schema between your target and your source. On top of that, because this is a compute application, you do have an option to do filtering and transformation. It supports multiple destination, and it's also support multiple source as well. Now, both Logstash and Data Prepper are similar tools in terms of the pipeline that they created and the migration that they run. The difference between making design decision of Logstash versus Data Prepper is Logstash has been around longer, hence it has more input plugins, it support more target and source, but it doesn't have a managed service options within AWS. Data Prepper, on the other hand, has a managed service options that we discussed earlier called Amazon OpenSearch ingestion. So if you have your pipeline built on top of tools like Data Prepper, you do have an options to use a managed service version of that. The next critical path of your migration journey will be deciding on the cutover between the old cluster and the new cluster. And cutover period has two aspects to it. You can choose to pause ingestions, or if you can't afford to pause ingestions, then you may have to continue to use the older search engine or the older search cluster until the data is fully migrated. And the cutover differs between your search use case and your log analytics. So the 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 logs analytics typically is where you have a lot of writes operation coming in. Now, the the cutover with logs analytics typically happen in a dual write fashion where you have the source writing to your old log cluster and your new cluster on Amazon OpenSearch service. And with search, typically because this is a read heavy operation where majority of the customer can afford to pause ingestion, you can choose to pause ingestion, use a point of in time snapshot and restore, for example, to migrate over and then uh, continue ingestion to the new cluster entirely. Three options in logs analytics because you want to make sure that you maintain ingestion. You don't have any huge gap or huge latency when you do cut over from your previous log cluster to Amazon OpenSearch service. So you can have a dual write to both new cluster and old cluster until certain retention period ends where all of the log in the old cluster has been fully replaced by the log in the new cluster, then you can retire or decommission the old cluster. The second, if you have a budget window for pause ingestion at source, this is make this is one of the simple way to do cutover because you can pause ingestion, perform a snapshot and restore to the new Amazon OpenSearch service cluster, and then continue ingestion on the new one. The third option is a hybrid between the two where you have a full migration and then you sync the smaller chunk of data after the point in time after the point in time snapshot restore. So the diagram shown here show you the different two steps in making that cutover. For search workload, typically you will pause the ingestion from source to the current environment. So you will copy all of your data from the current environment through either snapshot restore or remote reindex to the target environment. You can have the read traffic still served by the old environment until your data is fully loaded to the new environment. Then you can switch over the write and read operation to the new cluster. The final phase in your migration journey is to make sure you have a plan to operate the cluster securely and at scale. There are six best practices areas when it comes to operating your cluster. The first one is making sure that you set up a proper CloudWatch alarm for alerting and monitoring. This will include things like monitoring your free storage space, monitoring your CPU utilization, monitoring your JVM memory pressure, because again, Amazon OpenSearch service are is a distributed system of Lucene indices, which is run as a Java processes. They will consume JVM and CPU. So monitoring those two resources are critical to make sure you have a healthy cluster. The second thing is, like we discussed in a sizing uh, discussion, the shot strategy may change once you grow the cluster in a search use case, on a log analytics use case. So revisit your search strategy to decide whether you need a new strategy, whether you need more shard or more nodes to anticipate your growth or not. The third best practice is to ensure stability by having the latest service software version, which is the control plane of the managed service, and then the version update of the OpenSearch itself. So any changes, any configuration changes within Amazon OpenSearch service is done through a blueprint deployment that will minimize the downtime, where the blue environment will still remain operation until the green environment has been successfully provisioned, has been successfully replicating all of the data and ready to serve a traffic. And this is managed by AWS, so you don't have to manage the blue-green deployment yourself, but this is managed for you as part of the managed service. And also to ensure that you have a backup strategy to make sure that if you need to restore the cluster to the same region or a different region, you do have backup strategy. You can use Snapshot as your backup, where you can snapshot your cluster or your index and put the snapshot in an S3 bucket within the same region or in a different region. The fourth best practice area will be performance, where you can enable auto tune that will give you recommendation and some minor changes against your cluster. The second aspect of performance is refresh interval. Refresh interval decides the elapsed time or the elapsed interval from the moment of your document ingested into Amazon OpenSearch until the moment that document is searchable. So by default, it's a 1 second refresh interval. If you can afford to have more latency in your ingesting, typically in a log analytics, then you can increase the refresh interval. This will reduce the resource consumption in your cluster entirely. And making sure that you have a proper security control in place within Amazon OpenSearch service. You can enable encryption at rest, node-to-node encryption, which is our recommendation. You do have an options to deploy your Amazon OpenSearch service cluster within the VPC or have a public access. So our recommendation is to deploy it within a VPC so you don't expose that endpoint publicly, and you can access that through a different connectivity like private link or transit gateway if you have a cross account or cross VPC application running outside of the VPC. The dashboard itself, OpenSearch dashboard, which is included within the managed service, you don't have to pay separately, you don't have to provision separately, support SAML authentication. So if you have a identity provider that supports SAML, whether it's Active Directory or Okta, and you have operators or DevOps engineers that requires access to your cluster through OpenSearch dashboard, you should enable SAML authentication. And in conjunction with that, we do have a fine-grained access control where you can decide access to a particular index or certain documents or a cluster level permission. And the sixth best practice area when you operate Amazon OpenSearch service is continuously look for opportunity to do cost optimization. Within AWS, we have a number of cost optimization recommendation for your Amazon OpenSearch service, starting from using Graviton instance, right size your cluster, making sure you have the right number of nodes, the right number of shard, up to leveraging things like reserve instances. When using or selecting a deployment option of Amazon OpenSearch serverless, however, there are certain areas there that are managed by AWS, such as your stat strategy is managed by AWS. The performance is also managed and auto scaled by AWS. That concludes the migration journey that customer typically execute when migrating from their existing cluster or from their existing solution into Amazon OpenSearch service.
Thank you, Andy. It's time for Q&A, and there are a few questions that I see in the chat. So one question is Sharp strategy managed by AWS?
Yeah. So like I mentioned, when customers choose to use Amazon OpenSearch service, Amazon OpenSearch serverless, they don't have to decide on the number of shard. The number of shard actually abstract away from the customer. The stat strategy, including the number of shard, the size of the index data addressed by each shard, will be managed by AWS. This is available only in Amazon OpenSearch serverless.
And then Will is asking for the kind of the summary of best practices and whether there are like details listed in a white paper.
Yes. So this 6 phases in details like the actual cutover options, updating your DNS client is available in more details in the migration white paper.
All right. If there are any other questions, feel free to post them in the chat. Or if you want to go off mute, just raise your hand and we will unmute you.
As a possible next step, you can review the white paper in details. We do have a publicly available workshop for you to try out Amazon OpenSearch service that will include different queries supported within Amazon OpenSearch, different ingestion pipeline that you can use to Amazon OpenSearch. So the link to the workshop is there. You can also contact your account team to have a review of your current environment, making sure that you do have a possible migration path and what does the migration path would look like in details.
And I see that Will raised the hand. Bob or Andy, will you be able to unmute Will?
Yeah, it requires presenter. So if Andy, if you could unmute Will, that'd be great.
I will do that. I don't think I can, Michael. If you want to type in your questions in the chat box.
Yeah, for some reason my unmute is also blocked. Apologize for that. So Will, if you could just type your question in the chat, we'll pick it up immediately.
While doing that, I'll address that question from Kumar. Does serverless initiate a compute instance when any analytics? Yes. So by default, the Amazon OpenSearch serverless provision a compute capacity unit when you set up a new index under that collection. Yes, Will, that's a good technical questions. The index template are not part of the index data itself. The index template are actually part of the cluster. So if you do have an index template, then you need to provision that, or you need to add that manually through, well, not manually, but typically we put the index template in a change management repository. And then when you set up a new one, when you set up a new cluster, that's when the change management also apply to the new cluster. So you can put the index template in a Git repository, for example, and then as part of your deployment strategy, you will deploy that index template as part of the change management into the new cluster. So things like index template, index state management, we recommend people to manage that in a separate Git repository, for example. So yeah, you can use, so if you have a Bitbucket Git repository, for example, you can set up a webhook for your index template and run a pipeline. So when you update or when you add new index template into your Git repository, then Bitbucket or code commit will use code deploy to deploy those template into Amazon OpenSearch service. Yeah, it's not to Terraform. It's yeah, Atlantis is Terraform specific. So from Git repo, you can use something like code deploy, or you can use a simple webhook that will then deploy, because index templates is JSON and there are APIs endpoint in your Amazon OpenSearch service that you can use to deploy that index template. All right, Michael, back to you.
Yes, yeah, I think we're over time here, but if you have any other questions, feel free to contact us directly, and you can see our contacts on the screen right now. Also, just a quick reminder to take the survey. It will take you less than 2 minutes to complete, and we really appreciate your feedback. With this, we are concluding this session. Again, thank you very much for attending, and we'll look forward to see you on our future events. So with this, have a great rest of the day. Thank you.